Hello, welcome to this class. Good to see you, good to have you. This is Uncle Johnson Explains. Welcome. If you're visiting us for the first time, click the subscribe button. You can email, give me a response. You can call, you can chat me up on WhatsApp. I'm just a simple fellow you can flow with. And this is a geometry class. I'm gonna be going with the phase one. Maybe this is gonna actually have a phase two. Check out for it next time. Okay, introduction. So on this geometry class, I'm gonna be taking you with a whole lot of information, or let me say major things concerning the first facet of geometry, and this is the phase one. Okay, I said in the note, geometry is an aspect of mathematics that deals with different shape. Okay, in mathematics we studied shape. I know back then in primary school or in your junior classes you did shape. You talked about circles, you talked about your rectangles, you talked about your triangles, and so many other shape of your interest. Wow, and that was good. But in this class I had to actually put this in italics because we're going to be focusing mainly on angles. So today we're going to be talking about about angles. It involves angles, that is geometry, parallel lines, triangles, polygons, and circles. Okay, let's go into angles now. An angle, according to notes or my notes, I said an angle is a measure of rotation. Angles are measured in degrees. Now, assuming we have this line intersecting here, let's say it forms an angle here, it also forms an angle here, it forms an angle here, and also forms an angle here. So these points where it meets are where it forms an angles, and we said by definition an angle is a measure of rotation which are measured in degrees. So this can be, let's say, x degrees variables, or let's say y degrees, let's say p degrees, or whatever. Now an angle is formed when two or more lines meet. So let's say this is line A, this is line AB meeting another line, let's say K, and probably here was, let's say this point now was actually Z before they met. This is Z, but when they met they now formed an angle here. So angles are formed when two or more lines meet. Like in this case we had so many lines meeting to form this angle. Now this point where the angle meets is called the vertex. This is called the vertex. Okay, the vertex. Okay, I think I gotta highlight this so your mind can always get your mind on this. Okay, this is the vertex. Okay, let's go to the next slide. Okay, types of angles. We have acute angle. Okay, an acute angle is an angle that is less than 90 degrees. So right here this angle can be 80 degrees, it can be 70 degrees, are you getting me? But provided it's less than 90 degree, that makes it an acute angle. Okay, that's the first type of angle we're treating today. And the other angle we have is a right angle triangle. A right angle triangle have this kind of square symbol here, and we say it's equal to 90 degrees. That is something that can also help you to recall your right angle triangles. They have something like square right here, and they're equal to 90 degrees. Okay, we have another angle, obtuse angle. This is an angle greater than 90 degrees but less than 180 degrees. So we have an obtuse angle here. Right here we might be having 150 degrees measure of an angle. So it is actually more than 90, just like we said here, is actually more than 90, but definitely it is not more than, what's it called, it is no more than your 180 degrees. Sorry, I got to get my highlighter. It is no more than 180 degrees. So that's it. Okay, back to this. The next one is a reflex angle. A reflex angle is an angle which is more than 180 degrees but is actually less than 360 degrees. So that's one thing we know about the reflex angle. Okay, so in this reflex angle, this measure can be about 230 degrees. Wow, or let's say 256 or 197, but it's actually greater than your 180 degrees but less than 360 degrees. Okay, let's get on. Now the next one we have is straight line angles. Straight line angles are actually angles formed in a straight line. These angles are exactly 180 degrees. The next thing we'll talk about are complementary angles. Now, if you watch this particular diagram in these complementary angles, we'll have two angles right here. Okay, sorry for that. Okay, we'll have two angle X and angle Y. Now, remember what I told you previously, just a few minutes ago. I told you in a right angle triangle, see something like this or a square, which denote that this angle makes up to 90 degrees. So in this particular place now, X and Y, they are complementary, which means they are summing up to 90 degrees. Okay, let's say for an example, X is equal to 50 degrees. Let's solve for Y. So right here we have that X plus Y is equal to 90 degrees. Why is it 90 degrees? It's 90 degrees because they are complementary angles, and we say that complementary angles add up to 90 degrees. So we defined our X as 50, Y as the variable, and then 90 degrees. Now we apply our basic skills of algebra, that is collecting like terms. So if we actually collect like terms here, collect like terms, okay, we're going to be having that Y is equal to 90 minus 50, and therefore our Y becomes 40 degrees. So that makes sense. Okay, let's go to the next one. We have supplementary angles. These are angles that sum up to 180 degrees, just like exactly your angle, not just like that is exactly your angle in a straight line. So let's say this is angle K, and we'll have another angle here, angle M. Wow. Okay, let's say K is equal to, let's say, or M is equal to 110 degrees. So can we make any sense out of this? If K plus M is equal to 180 degrees, let's solve for K, since we assumed M to be 110. So K, we don't know, we know M as 110 equal to 180 degrees. Now we'll collect like terms here, basic skills of algebra. Then we'll have 180 subtracting 110. Okay, so K 180 minus 110, that will be giving us 70 degrees. Okay, now an angle at a point sum up to 360 degrees. So we have different angles. Now if you watch where all these angles are focused on this central point, maybe I got to add a highlighter to this, on this central point. Watch them, they all have an origin right here. You see them? Okay, so let's say this can be angle X, Y, K, L, P. You get? And all of them sums up to 360 degrees. Don't forget this. Supplementary angles or angles in a straight line add up to 180 degrees. Complementary angles 90 degrees, and angles at a point add up to 360 degrees. Okay, let's continue. Okay, let's talk about parallel lines and transversals. What are parallel lines? Parallel lines are lines that can never meet no matter how they are drawn. Okay, for example, we have some lines on our screen right here. Now, this is line, let's say line K, L, and line AC, AB, for example. Now, this line KL, so I wrote my L like a C, line KL. If you watch here now, no matter how I extend these lines, even if I wish to draw them longer than this, you understand, they can never meet each other, so they are parallel. Same thing applies. It doesn't matter if they are horizontal, just like we have here, these lines are actually horizontal, so it doesn't oh, sorry for that. So it doesn't actually matter if they are horizontal or vertical. So these horizontal lines are, they are parallel, and also these vertical lines, let's say line MN OC, they are also parallel lines because they can never meet no matter how they are drawn. Okay, while here we have perpendicular lines. Perpendicular lines. Okay, perpendicular lines. Why are they perpendicular lines? They are lines that meet at a point to form a total of 90 degrees. Remember the symbol we did a few minutes ago or a few seconds ago, and I told you about it. I told you this is a symbol that denotes that we have an angle, a right angle triangle, a right angle, sorry, or an angle that sums up to 90 degrees. Okay, let's continue. So right here, these lines, they actually intersect, and when they intersect, they formed an angle. But you know one funny thing, when they formed an angle here, it wasn't up to 90 degrees, so we can just say they intersected. So this is an intersection. We have an intersection here, intersection. Okay, so I think this is going to really make sense, because if you watch here, they actually intersected here, but they don't add up to, they don't in any way denote any sign of 90 degrees. Okay, other relationship between angles. We have alternate angles, they are equal. I'm going to explain that just in a minute. Opposite interior angles, corresponding angles, and vertically opposite angle. So whenever we have, I didn't talk about transversals. Okay, like for this, for example, now if we have a line cutting, I know I told you about parallel lines, right? Okay, if we have a line cutting across this parallel line, this line cutting across it is known as a transversal. Don't mind the fact that I had to, kind of obstruct my, what is it called, horizontal line here. So it can also happen here. If I have a line cutting across this point, this line is also known as a transversal. So a transversal is a line that cuts across a parallel line, or that cuts across a line. Okay, so let's get back to this. So we'll have a transversal here. So this is a transversal, this transversal line, and then we'll have two parallel lines. Now, right here, an angle is formed right here. Also, an angle is formed right here, right? So we also have an angle formed here. We have another angle formed here. We also have an angle formed here. We have an angle formed here. We have another angle formed here, and we also have an angle formed here. Remember what I told you in the beginning of this class earlier? I told you that angles are formed when two or more lines meet, and if you have been consistent listening, paying attention, you discover that there is an intersection here. I've talked about that. So these lines, they all met here, and because they met there, actually or definitely will have an angle formed. So can we just name these angles? Let's say angle A, B, C, K, E, X, Y, M. So I've named this angle so that I can use that to explain this relationship we have here. Okay, I start with the alternate angles. Just a minute. Okay, I'm going to start with the alternate angles. Okay, so starting with this first. Okay, alternate angles. Alternate angles, just from the word alternate, the angles are alternate to each other. So I'm going to just use that to explain this. So if you watch here, you watch E and K. So E and K, they are actually alternate, and we see that alternate angles are equal. So E is equal to K. They are alternate angles, and the angle that's alternate here is C and M. They are alternate angles. And whenever you are looking at for alternate angles, observe something like your Z and C's. So we have watch here. So you watch this, you see this. So this is a Z, and this is the Z and C's. So if I had considered this part, watch, just try to pay attention, you can understand. If I had considered this part to be my Z, you get now. So my Z going moving towards this end, I get me. So you watch this part alternate to this part, and then if I had considered my Z coming from this angle going down to this part up to this part, you have this alternate to this. So don't mind the fact that my diagram kind of um was so busy. Don't mind the fact, but I know you're gonna definitely understand what I'm talking about. Okay. Wow, wow, wow. So getting so many things off here. Let's just get back to what we're talking about. So I had an angle here. So this is angle C. Don't forget angle K. Okay, this is angle E. Okay, this is angle M. So angle C is alternate to angle M. So these angles are alternates. Sorry for that. These angles are alternates. Just get your mind fixed to this. They are alternate angles, and they are equal. So if C was 50 degrees, it actually implies that M is also 50 degrees. Okay, the next one we're going to talk about right now is the opposite interior angles. Opposite interior angles. Okay, and they sum up to 180. So in this particular diagram, remember, don't forget our line. Okay, right here we have these two angles, E and C. If you watch well, they are opposite each other and they are in the interior. Remember, this is the exterior angles in this diagram, the exteriors, but these are the interiors, the interiors. So at this point, E and C are opposite and the interior angles K and M are opposite. Therefore, we have that E plus C is equal to 180 degrees. Why are they not the same? From our definition, we say that opposite interior angles sum up to 180 degrees. So that is why they are summing up to 180 degrees. So same thing happens here. M plus K sums up to 180 degrees. Okay, the next one we're going to be talking about right now, so we're going to be talking about is, okay, just in the mid. Okay, the next one we're going to talk about is corresponding angles. Okay, now we say they are the same. Let me just get rid of some of this thing to get our environment clear. Okay, I know you understood this very well, so I think I can clean it, right? Yeah. You should get your mind fixed to this. Okay, so we're talking about corresponding angles. In corresponding angles, the way they relate is that we have one angle outside the diagram and we have one inside. So right here, A is corresponding to E, B is corresponding to M, Y is corresponding to K, and X is corresponding to C. I think I just have to say it again. We'll have one angle outside at the exterior and one angle inside in the interior. So the outside corresponds to the one inside. Are you getting me? So right here, A is corresponding to E, B is corresponding to M, and they'll still be in the same phase of the transversal line. X is corresponding to C, and Y is corresponding to K. Okay, let me just get some things cleaned in this diagram so that we can, for better understanding. Okay, it looks so busy. Okay, wow. Now vertical opposite angle. So I think I need to draw another diagram for vertical opposite angle. Okay, if we have two parallel lines and have a transversal cutting across them, we have an angle formed here and also an angle formed here. We can also have an angle formed here and angle formed here. Now let's say we have angle K here, angle F here, angle X here, angle Y. Angle K is vertically opposite to angle F, and we say they are equal. And angle X is vertically opposite to angle Y. So here, angle A is vertically opposite to angle K. Okay, sorry for that. So angle A is vertically opposite for angle K, and then angle B is vertically opposite angle C. E is vertically opposite angle Y, and angle M is vertically opposite angle X. I believe with that, I think you're going to have a good idea of what to talk about. We'll talk about vertically opposite angles. And we are actually done with the types of angles. So I think right now we can move on, right? We can actually move on. Okay, so have a question to answer. Okay, what's the question? So under application and tax, we have solve for the value of the unknown. So we have an angle formed here, hope you know, an angle formed here, an angle formed here, an angle formed here. Now these two are vertically opposite, hope you know, and these two are actually vertically opposite. But before that, this unknown angle is called K, this unknown angle is called N, this unknown angle is called F. So solution, so that we can get right to solving this question. Solution. From here we can see that angle K is equal to 110 degrees. How do we know that? The reason is that they are vertically opposite. Vertically opposite angles. Hope you know this is sign of angle. Okay. Another thing we'll have to solve for here. So we find our K. And that stuff we have to go for now is the N. Okay. You can solve for N in two ways. Or let's just use a simpler method, a simpler format. Now, if you can be careful here, you observe that angle N is in a straight line with 110 degrees. So it implies or employs that they are angle at on a straight line or supplementary angles. So N plus 110 degrees gives us 180 degrees. We apply our basic algebra skills, which is collect like terms here. Collect like terms, and once we do that, we're going to be having that N is equal to 180 minus 110, and N will be giving us a 70 degrees. Now we know N as 70 degrees, and we know that K is also equal to 110 degrees. How can we find F? Now remember, N is also equal to F. You get? So they are vertically opposite. Or you can also consider K and F as angles in a straight line. If you do that, it will help you and you're going to solve it. So if we consider them like that, we can sum them up together equal to 180 degrees. We'll still solve and still get the same answer. But we know that N is equal to F, so it means that F equals to 70 degrees. And what's the reason? They are vertically opposite. Vertically opposite angles. Okay, the next one, let's go to the next slide. Okay, we'll have a parallel line and a transversal cutting across the parallel line. So we'll have angle W here and a 90 degrees angle. We'll have angle P and angle T, and they said solve for the unknown angles. Solution. Let's go ahead and solve this question. Okay, now I tell people to solve this kind of question, start from the known while you approach the unknown. Okay, so we know this angle. It means we're going to start from here. We can't just start from here because we don't have any idea of what these values are. So we'll start from the known, going towards the unknown. Okay, so let's start from here. The angle closest to this is W, and they have a relationship between them. And what's that? If you watch well, or if you can be careful to observe, you'll see that this is a straight line. So angles in a straight line. Okay, so we'll have that W plus 96 equal to 180 degrees. And what's the reason for that? They are supplementary angles. Sorry for that. Supplementary angles or angles in a straight line. So collect like terms here. Basic skills of algebra equal to 180 minus 96. And what would that be giving us? 180 minus 96. Okay. And then 17 minus 9. Okay, what would that be giving us? Let me just get my head fixed. 17 minus 9 be giving me 8. Okay, so 84 degrees. Or let me just put it here. Therefore, W gives us 84 degrees. Okay, that's for W. So, but we know that W is corresponding to this. So, we can actually form an angle here. Can actually say, let's form an angle here and then solve for the angle. But there's also another law that can help us here. If you observe, or if you're careful enough, you notice that 96 is alternate to T. So, we cannot say that, can actually say that T is equal to 96 degrees because they are alternate angles, and we say that alternate angles are equal. So reason for that is that alternate angles. Okay, now we'll find T to be alternate. How can we find P if T is 96 degrees, and the reason for that is alternate? And if you can observe very well, if you're careful enough, you see that actually P is vertically opposite to T, right? So because of that, we'll have that angle P is equal to T, therefore P is equal to 96 degree also. And what's the reason for that? They are vertically opposite angles. Wow, that's cool. So the next slide we'll have this, and right here we'll have, wow, 4x. So it's an angle, so it's going to be 4x degrees, 6x degrees, 3x degrees, and 5x degrees. Okay, solution. Let's go ahead and solve this question. Now remember, we said angles are formed when they meet, when lines meet at a point. So you watch all this line meeting at a point, right? So that's making sense. So it means that 4x plus 6x plus 3x plus 5x is equal to 360 degrees, because that's the sum of angles at a point. So 4 plus 6 gives us 10. 10 plus 3 is 13, and 13 plus 5, because they are x, they can actually sum up comfortably. So we have 18x equal to 360 degrees. Okay, because we want to make x standalone, it simply implies that we have to divide both sides by 18. So divide both sides by 18. So I want to continue here. So we have that 18x equal to 360, all divided by 18. So 18 cancels at 18 here, x stands alone, and 360 divided by 18 is giving us 360 divided by 18. Okay, it's giving us 20. Wow. So it gives us 20 degrees. It means that x is 20 degrees. So if we want to calculate for the individual components here, we'll have that 6 bracket 20, and that will be giving us 120 degrees, right? So we'll have 120 degrees. So same thing happens here. We'll have that 3 bracket 20, and that will be giving us 3 times 20, that will be giving us 60 degrees. Same thing applies here. Here is 100 degrees, and here is 80 degrees. So let's add these numbers up and check if that's going to make sense to us. 80 plus 120. So let's do it here. 80 plus 120 plus 100. Okay, we're having 120 plus 80 is 200 plus 100, 300, now plus 60. That's going to give us 360 degrees. So that makes sense, because all the angles right here, all the angles right here, you know, all these angles, they also sum up to 360 degrees. So let's go to the last slide. Wow, we'll have angle here 60 degrees. We'll have an angle here. Okay, we'll have an angle here 230 degrees, and we'll have angle W, and we also have angle Y. And they say so for the value of the lettered angles. Lettered angles here we know are W and then the Y. then y. Okay, solution. Let's go ahead and solve this. This is an angle at a point. An angle at a point, yes, because this line coming here, this line coming here, and they form here to give us an angle at a point. Okay, and that is a reflex angle, right? Now, angle at a point is 260 degrees, so it means that 230 plus W equal to 360 degrees. So to find out W, we'll have that, so collect like times W equal to 260 minus 230. So W gives us, okay, 130 degrees. So we found, so therefore W is equal to 130 degrees. Don't mind my irritation. So that's it. We found our W. Okay, how can we get Y right now? Okay, I think I have to redraw this to give us a better sense of what this diagram is gonna actually be like. Okay, I think I'm gonna have, okay, just watch this now. Okay, oh, so have 60 degrees here, don't forget, and we'll have now, okay, I want to work with this place, guys. I'm not gonna cause any much tension here. So I want to construct, or I want to dissect this line. If I should dissect this line, sorry, that didn't give me what I actually wanted. Okay, okay, let me dissect this line. If I should dissect this line, okay, remember, I know that everything here is giving me, what's it called, from W is giving me 130 degrees. I have that in mind. And remember, I told you about the, okay, we are solving for Y, right? We don't need this 230 here again, so we can just get rid of it. We're done working with it. Okay, I told you about the Z's, right? The Z's. So we'll have the Z's. If you watch our Z, like I told you, see that the Z here, it simply implies that any angle we have here will be alternate to any angle we have here, right? Okay, so let's call this other angle let's call an angle here, angle M. If we have angle M here, not W, if we have angle M here, which is unknown, and then all the angles here is summing up to 130, it simply means that we have M plus, and remember this one is also alternate to this, so if you watch, we have another Z here, right? Another Z here and another Z here. So, and because they are alternate and we know this value, so you can actually plug in 60 right here. So M plus 60 equal to 130 degrees. That is total angle here. Okay, so collect like times M equal to 130 minus 60, and M will be giving us, okay, let me just do some manual calculation to get this done. Okay, I'm getting 70 degrees. Okay, wow, that's it. So the relationship here was that, okay, or the confusing thing here for some persons is that I had to apply or employ the principle of alternate angles. So this angle, if I had dissected here, just follow closely, if I had dissected here, okay, if I dissected here, this angle, the angle here, any angle here will be alternate to any angle here, and any angle here will be alternate to any angle here. So that's it. Wow, that was a wonderful one. It was cool having you guys around. It was very much cool. So remember, this is Uncle Johnson Explains. Send an email, call. Thank you so much for watching. I really do appreciate, and I'm grateful. Have a nice time. Just keep learning.